Good evening. I've been having a lot of letters about those two very brilliant objects in the southwestern sky after sunset. People want to know what they are. They are, in fact, the two brilliant planets, Venus and Jupiter. And this seems rather a good time, therefore, to say something about them. Well, you can't mistake them. Jupiter is rather the higher up of the two, below the square of Pegasus. Venus is lower down and even brighter. In fact, brighter than anything else in the sky apart from the sun and the moon. They're quite close together, and we'll get a bit closer as time goes on. I may say we've had the usual talk about alignments of planets which will affect the Earth. I can assure you that's absolute nonsense. The planets will not line up, and even if they did, it couldn't affect anybody or anything. So let's begin by having a look at Venus, which is closer to the sun than we are, and just about the same size as the Earth. But it's a very different kind of world. That picture of it was taken with the Palomar 200-inch reflector, and frankly, it doesn't show very much apart from a featureless crescent. And that is because we are not seeing the solid surface of Venus at all. All we are seeing is the top part of a layer of cloud. And you will never see much more than that. Here's a drawing of Venus I made a few evenings ago with my 15-inch reflector. And you can see there a very vague cloudy feature, which is a cloud and nothing more, and not much else. But you will see that the disk is not round. And that is because Venus, being closer to the sun than we are, seems to show phases like those of the moon from new to full. As you know, the planets, like the moon, shine only by reflected sunlight, so the sunward side shines and the night side doesn't. So let's have a look at a diagram with the sun in the middle, Earth at the bottom, and there is Venus in the new position with its dark side turned towards the Earth. Now Venus takes nearly 225 Earth days to go around the sun, and as it moves on, a little of the lighted side begins to be turned in our direction. Venus becomes a half, and then it becomes a three-quarter or gibbous shape, and increases very slowly until it becomes full. But when it's full, it's on the other side of the sun, and therefore it's virtually behind the sun in the sky, and we can't see it at all. It then moves on, it becomes three-quarter or gibbous again, and it's just about in that stage now, and then it shrinks to a half again, a narrowing crescent, and then returns to new, which it will do next June. And Venus always does behave like that. But sometimes, when Venus is new, it passes straight between the Earth and the sun. The lining up is perfect there. And we have what's called a transit of Venus. And there's a picture of a transit of Venus shown as the transit of 1882. And you know, there can't be anyone now living who remembers the transit of Venus, because there hasn't been one since 1882. And the next one won't be until the year 2004. And I can assure you, we'll do a special Sky at Night program about it then. But what is Venus really like? Before the space age, we didn't know a great deal about it, and Venus was often regarded as the planet of mystery. What we could do was to analyze the upper atmosphere by means of the spectroscope, and from that we found out that Venus has an atmosphere made up very largely of carbon dioxide. Now, carbon dioxide has the effect of a greenhouse and shuts in the sun's heat, so we knew Venus must be pretty hot. The sun's rays strike the Earth, and many of them then go out into space again. In the case of Venus, a good deal of the sun's radiation is sent back by the carbon dioxide in the atmosphere, and therefore we expected Venus to have a very torrid climate indeed. But just how hot, we didn't know. And we didn't even know how long Venus took to spin on its axis. It turned out to be 243 days later on. And we didn't even know whether Venus was all land, or all sea, or a mixture of both. And there were some other intriguing things too. What about the so-called Ashen Light? When you look at the moon, when the moon's a crescent, you can very often see the dark side shining faintly, as in this rather lovely picture by Douglas Arnold. But there's no mystery about that. It's due to light sent from the Earth onto the moon and lighting up the dark side, so we call it the Earthshine. But we see the same kind of effect with Venus. Not nearly so prominently, I can assure you. This is a drawing I made some time ago, again with my 15-inch telescope, and that does show the faint luminosity of the dark side, the Ashen Light. But believe me, I've exaggerated it wildly, because otherwise you wouldn't have seen it at all. It was very near the limit of visibility. Well, what causes it? I think most serious observers of the planet have seen it, but there were some wild theories around. In the last century, there was a German astronomer who rejoiced in the name of Franz von Paula-Greithuysen, and he suggested seriously that the Ashen Light might be due to vast forest fires lit on the surface of Venus by the local inhabitants to celebrate the election of a new government. And that, frankly, strikes me as being rather unlikely. And it's far more probable that that effect is due to electrical storms in Venus's upper atmosphere. But as I say, before the space age, our knowledge of Venus was really pretty meager. And it was only in 1962 that we started to learn more, because that was the year of the first successful interplanetary probe, America's Mariner 2. And that passed by Venus at a distance of less than 20,000 miles and sent back the first close-range information. And straight away, the ocean theory was killed stone dead, because Mariner 2 showed that Venus is very much too hot for any kind of water to exist, even under those conditions. So Venus had to be all land, and the possible existence of life there started to seem even less likely. Now, Mariner 2 didn't carry any cameras. Later probes did, and here's a very good picture sent back by Mariner 10 in 1973 as it bypassed Venus on its way to Mercury. And there again you can see the cloud structures, but you can't see very much else. And without landing probes, you couldn't learn very much else. And that was what the Russians set out to do. Their aim was to drop probes down gently through the atmosphere of Venus and soft land them on the surface so they could get back pictures. They had several failures, but then in 1975 they succeeded, and there's one of the earliest pictures sent back by the probe Venera 9. You can see the part of the spacecraft there and the rocks in the background. It doesn't look very friendly. Well, that was the end of the start. The Russians have had more major successes there. Well, just look at this picture from Venera 13. And this is a color view, and that color is genuine because the rocks of Venus are so hot they're actually glowing orange in the sun's heat. And there again is part of the spacecraft. And the resolution on that picture is pretty good. But even that's been surpassed more recently by Veneras 14 and 15. And this is a very recent picture we've just received. And the resolution of that picture is really extraordinarily high, something like 3,000 feet. And so we really know what Venus looks like. But of course, we haven't actually got pictures of the probes themselves. The Americans have dropped probes on the surface also, the Pioneer landers, and there's an impression of what a Pioneer lander may have looked like. But it wouldn't persist for long, and none of those landing probes can go on transmitting for more than a fairly few hours because of the intensely hostile conditions. And so they're put out of action quite quickly, and you can't remain in touch with them as you can with the probes that have soft landed upon Mars. But we can never actually see the surface directly, so how can we map it? From above the clouds, well, all you can see is the top part of the cloud layer. And there's a picture taken by America's Pioneer as it neared Venus, and again, it doesn't show very much. The only way to map the surface is by means of radar. And that has been done both from Earth and from radar equipment carried in probes going around Venus. And there is a picture of part of Venus's hemisphere. It's not, by the way, land and sea. This is merely a contour map. The blue areas are low-lying, and the green and the yellows are higher up, so please don't mistake it for land and sea. But by now, we have got a map of the surface. There are two major upland areas. One's called Aphrodite, near Venus's equator, and the other is called Ishtar. And bordering Ishtar are the very lofty Maxwell Mountains, which are as high as our Everest. And that's an interesting area. But I think even more interesting is the region we call Beta Regio, and that appears to be highly volcanic. And there is a radar picture of it. The V marks, V12 and so on, they indicate areas where the Russian Veneras have landed and from which they've sent back pictures. But look at the top part, the high altitude indicated by yellow. And there we have two shield volcanoes, Riamons and Thiamons, which are very much the same in type, we think, as our own shield volcanoes, but considerably larger and more massive. Now, on Earth, a volcano arises above a hot spot below the Earth's crust, and the magma wells out and the volcano erupts. But on Earth, according to the science of what we call plate tectonics, the crust is moving with respect to the mantle. And so after a time, the volcano moves away from the hot spot, and it ceases to erupt, and a new volcano appears over the area where the hot spot is. And that's why our own volcanoes don't persist indefinitely. And there's a very good example of that in Hawaii, where we have the two biggest shield volcanoes, Mauna Kea and Mauna Loa, both about 14,000 feet high. Now, of those, Mauna Kea is extinct. At least I sincerely hope it is, because one of the world's major observatories has been built on the top. And there's a view of Mauna Kea. We took that one of our recent Sky at Night programs. And that building in the foreground is the observatory of the great James Clerk Maxwell telescope. Well, Mauna Kea is extinct. From its top, you have a very good view of Mauna Loa, which is about the same height and is very far from extinct. It's violently active. But over the course of time, Mauna Loa also will drift away from the hot spot, it will cease to erupt, and a new volcano will appear. Now, that's happened on Earth. Not so on Venus, where the crust appears to be much thicker, and we don't have the same kind of plate tectonics. And therefore, on Venus, when a volcano starts, it keeps on, so to speak. It doesn't move away. And that's why we think that Riamons and Thiamons are very much larger and more massive and probably more active than our volcanoes of Hawaii. And there's an impression of what one of them might be like. And I just wonder whether that's accurate. I think it probably is. But you know, Venus as a world is just about as hostile as it can be. We now know that the surface temperature is, as I've said, not far short of 1,000 degrees Fahrenheit. The atmosphere is mainly carbon dioxide. The atmospheric pressure is about 90 times the pressure of the Earth's air at sea level, and those lovely-looking clouds are made up chiefly of sulfuric acid. And so, instead of being welcoming, Venus is very much more like the conventional impression of hell, and there may be continuous thunder and lightning. And just why is this so? Remember, Venus and the Earth are just about the same size, and so you might imagine they'd be in the same state, but they certainly aren't. And I'm sure the reason must be that Venus is much closer to the Sun, only 67 million miles out as against our 93 million. And there's a new theory now, due to 3 American astronomers, and this is so-called the wet greenhouse theory. And if they're right, and they may well be, then there was a period in Venus's history when there was an ocean almost at boiling point. So Venus then had hot seas. So let's now go back to the start of the early story of the solar system, more than 4,000 million years ago. In those days, apparently the Sun was less violent than it is now. And Venus and the Earth probably started to evolve along the same lines, with oceans and continents and the same kind of atmospheres. But then, very gradually, the Sun became hotter. Now, the Earth, at 93 million miles, was more or less out of harm's way. Venus was not. And therefore, the temperature started to rise, and the oceans became extremely hot, and they started to evaporate. And they went on evaporating until about 50% of the atmosphere was water vapor. But then the evaporation stopped because of the increasing water vapor pressure in the atmosphere. But the hydrogen went on escaping from the top part of the atmosphere, and that was slowly replenished by evaporation from below. And by staying liquid for millions of years, the oceans were able to move the original huge mass of carbon dioxide out of the atmosphere, converting it to carbonate rocks in Venus's crust. And that reduced the density of the atmosphere until probably it was no greater than that of the Earth's air at the present moment. And only later did the atmosphere pressure start to build up again. But by the time that thinning out process had ended, Venus had lost its water and the oceans were no more. You see, the water had been converted into hydrogen and oxygen. The hydrogen had escaped, as I've shown you, and the oxygen had been combined with crustal materials to form oxygen-rich minerals such as magnetite, hematite, and so on. And that could be why Venus is so different from the Earth and has been now for a very long time. But I wonder, has any life appeared there? Well, if that picture is correct, as I say, it may well be, there was a period when Venus and the Earth were not too unlike, and I suppose life might have appeared there, but probably it didn't have time to get very far, if indeed it appeared at all. And I don't think we're going to know that until we have succeeded in obtaining samples of Venus's crust. Well, we certainly can't land astronauts there. I think that's quite out of the question. But we have already obtained materials from the Moon by purely automatic probes. We should be able to do so with Mars, and possibly with Venus also. And I think only then, when we analyze these materials in our laboratories, will we know whether Venus has ever had life. My bet is that it hasn't, and I don't think we're going to find any fossils in Venus's rocks, but of course I may be wrong. We've got to wait and see. But if not, then the only possibility, I suppose, remains with Mars, where life is very unlikely, but not entirely out of the question, I suppose, in a very modified form. But Mars at the moment is coming closer to us, and I'll have a great deal more to say about it in the summer when it's going to be well placed. So, for the moment, let's leave Venus and turn to the other brilliant planet, Jupiter, which is a very different kind of world. It's rather higher up than Venus at the moment. It's not so bright, but that, of course, is not because it's smaller. It's a great deal larger. Jupiter is so big you could throw more than 1,000 Earths inside it and still leave room to spare. But it's a very long way away. Its mean distance from the Sun is 483 million miles, and it's way out beyond the asteroid belt. And it takes nearly 12 years to go once around the Sun. Now, unlike the Earth, it's not solid and rocky. Neither is it like Venus, with a rocky surface overlaid by an atmosphere. We believe that Jupiter is built up in a very different kind of way. There's probably an iron silicate core with a temperature of something like 30,000 degrees, surrounded by layers of hydrogen. And beyond those layers is the hydrogen-rich atmosphere that we can actually see. And when you look at Jupiter through a telescope, you can see quite a lot of detail. That was a view I had a few nights ago. You can see there the belts and the bright zones. Also see that Jupiter is flattened because although it has such a long year, it spins round very quickly in less than 10 hours, and therefore the equator bulges out. Now, if you look there to the upper left above the main belt, you can see a kind of a hollow. And that marks the area where we very often see that extraordinary feature, the Great Red Spot. Now, that's a view from Earth. There are 4 probes that have bypassed Jupiter, 2 Pioneers and 2 Voyagers, and they've sent back splendid close-range pictures, showing far more detail than we can possibly see from the Earth. And there is a Voyager picture of Jupiter. You can see the vivid colors there. You can also see the Great Red Spot, which has a surface area greater than that of the Earth, and we believe that the color is probably due to nothing more or less than phosphorus. And time-lapse pictures taken by Voyager actually show the Great Red Spot spinning round, so we know it is a whirling storm, a kind of phenomenon of Jovian weather. How long it's going to last, we don't know, but it's been under observation now for a couple of 100 years, and certainly it has quite a long life expectancy ahead of it. There's nothing quite like that on any other planet. So Jupiter certainly is not a world we can visit, if only because there's nothing solid to land on, and of course also it's surrounded by zones of deadly radiation. There should have been another probe on its way there now, the Galileo probe. That, sadly, has been held up by the American shuttle disaster. It won't now be launched before next year, and it won't get to Jupiter before about 1995. But when it does, it should tell us a great deal more. It will study not only Jupiter, but also its satellites. And Jupiter has a whole family of satellites. Most of them are very small, but there are 4 which are big: Io, Europa, Ganymede, and Callisto. And they are planet-sized. In fact, Ganymede is actually a bit larger than Mercury, Callisto a bit smaller, and Io a bit larger than our moon, and only Europa is smaller. And you can see those with any small telescope, but from Earth, obviously, we can't see any relevant detail on their surfaces. But the Voyagers have sent us back splendid pictures. It turns out that Ganymede and Callisto are icy and cratered, Europa is icy and smooth, and Io is yellowish red and violently volcanic, and the surface is covered with sulfur. And those are active volcanoes on the surface of Io, totally unsuspected before the Voyagers made their journeys. And I wonder what an Ionian volcano may be like. Possibly something like that. But I'm quite sure that Io is one world we are never going to visit. There's no appreciable atmosphere, the surface is wildly unstable, and it moves right in the middle of Jupiter's dangerous radiation. So Io must be viewed from a very respectful distance. So you see, both these brilliant planets have much to offer. You can see more surface detail on Jupiter, and it's fascinating to watch the belts and the spots and the satellites as they move round. But don't forget Venus also, and as the weeks go by, you'll see the half shrink to a crescent until Venus becomes a slender crescent again in early June, and for a while we'll lose track of it. Now, before I go, one more interesting thing that's going to happen on March the 17th, and this is a total eclipse of the sun, when the moon passes in front of the sun and for a few minutes blots it out, and we see the lovely corona, or the solar atmosphere. And believe me, that's a magnificent sight. But please don't get excited. I'm afraid it occurs near our midnight, and therefore you won't see anything of it from here. You've got to go to somewhere such as the East Indies, the track crosses there, and also crosses the Philippine Islands, which frankly is where I hope to be. And if I do get any pictures, I'll show those to you in the April sky at night. But for next month, we're going to go on another different kind of journey. We're going to go to Williams Bay, outside Chicago in the United States, and there we're going to visit the Yerkes Observatory with the world's largest refractor, the 40-inch. So, until next month, good night.